Welcome to TechieWise. In today's session, we will be discussing perimeter root and discrete log. So these concepts, we will be using it in cryptographic techniques, encryption techniques, which we will be discussing further. Perimeter root. What is a perimeter root? A number alpha is a perimeter root modulo n if every number relatively prime to n is congruent to a power of alpha mod n. So to be more clear, alpha is said to be a perimeter root of prime number p if alpha power 1 mod p, alpha square mod p up to alpha power p minus 1 mod p are distinct. So we will raise to the powers of alpha from 1 to p minus 1 to check whether alpha is a perimeter root of p or not. Okay, it will be clear for us when we see an example. This 2 a perimeter root of 5. So 2 to the power of, so we have to check the values of 2 to the power of 1 mod 5, 2 square mod 5, 2 cube mod 5, 2 to the power of 4 mod 5. So we will stop with, that is we have to stop when p minus 1. So we have to proceed till p minus 1. So 2 to the power of 1 mod 5, 2. 2 to the power of 4 mod 5, 4, 2 cube mod 5, that is 8 mod 5 is 3, and then 2 to the power of 4 is 16, 16 mod 5 is 1. So here you can see I'm getting distinct values, 1, 2, 3, 4, none of the values are getting repeated. So the thing is, 2 is a perimeter root of 5. So if the values are distinct, then alpha is the perimeter root of p. We can see another example is 2 a perimeter root of 7. We are going to check whether 2 a perimeter root of 7. So what we have to do? We have to check for powers of 2. 2 to the power of 1 mod 7, 2 square mod 7, 2 cube mod 7, 2 to the power of 4 mod 7, 2 to the power of 5 mod 7, 2 to the power of 6 mod 7. We will stop with this, p minus 1. So 2 to the power of 1 mod 7 is 2. 2 square mod 7, 4 mod 7 is 4. 2 cube, that is 2 to the power of 2 cube is 8. 8 mod 7 is 1. 16 mod 7. What is 16 mod 7? It is 2. Here you can see it is getting repeated. So we can stop with this. We need not proceed further because the values are getting repeated. So 2 is not a perimeter root of 7. So we can see one more example. If 3 a perimeter root of 7. Please do check it out. 3 power 1 mod 7. What is 3 power 1 mod 7? 3 mod 7 is 3. 3 square mod 7. That is 3 square is 9. 9 mod 7 is 2. 3 cube mod 7, which is 27 mod 7, which is 6. 3 power 4 mod 7, you can check it out, you will get it as 4. 3 power 5 mod 7, you will get the value as 5. 3 power 6 mod 7, the value is 1. Here in this case, you can see we are getting distinct values 1, 2, 3, 4, 5, 6. Right? So 3 is a perimeter root of 7. So this is how we can check whether alpha is a perimeter root of p or not. Right? So now along with this, we can continue with discrete log. So how we can proceed with? So we can construct a discrete log table if alpha is a primitive. That is, I can construct a discrete log table of base alpha mod 7, mod p. So let me repeat. So I can construct a discrete log table of base alpha mod p if alpha is a primitive root of p, right? So now we can try constructing the discrete log table for already we have identified that true is the primitive root of 5, so we can easily construct that. So just we can start with discrete log. We are continuing with discrete log table construction. So here we are going to construct discrete log of base 2 mod 5, right? So here A and log 2 comma 5 of A. Already we have constructed. So here the possible values of A is going to be 1 to P minus 1. So 1, 2, 3, 4 are the possible values. So what is base log, discrete log of base 2 mod 5 of 1? So please do refer to these values. Refer to these values. So here value of A is this one, right? Value of A is this one. So what is the equivalent power here? 4, right? So here this is 4. So discrete log of base 2 mod 5 of 1 is 4. So what is discrete log of base 2 mod 5 of 2? Which is 1. Discrete log of base 2 mod 5 of 3 is this power, 3. Discrete log of base 2 mod 5 of 4 is 2. So this is how we will be constructing the discrete log table. So few cryptographic algorithms strength will be dependent upon the prime numbers and few will be dependent upon this discrete log. So what is that discrete log? Calculation of discrete log. So it is nothing but the equation y congruent to g power x mod p. Y congruent to, so discrete log calculation, discrete log calculation is y congruent to g power x mod p. So when we can find the value of x, provided we know g, x and p. So here in this case you can see I can find the value of A if I am provided with the 2 to the power of 1 mod 5. All these values we know. So if I am knowing all these values, then I can find. So if G is given, X is given and P is given, then we can find Y. So what is actually discrete log? So it is very difficult to calculate X. It is very difficult to calculate X. So if we are given with Y, G and P, then it will be difficult to find X. So using this property only few algorithms will be working, cryptographic algorithms will be working. So we can construct one more discrete log table for this one. So already we have, as discussed earlier, we can construct the discrete log of base alpha mod P provided alpha is a primitive root of P. I need the discrete entries, right? So now we can construct already we have identified that 3 is a primitive root of 7. So we can construct that. Now A 3, 7 of A. What are the possible values? 1 to 6. 1, 2, 3, 4, 5, 6. Right? Okay. So what is discrete log of base 3 mod 7 of 1? It is 6. Discrete log of base 3 mod 7 of 2, which is 2. Discrete log of base 3 mod 7 of 3, 1. And next is 4. And here 5 is 5. And 6 is 3. So this is how we will be proceeding with construction of the discrete log. Thank you.